Hello. So this is a follow-up video to the one I just recorded, where we solved a vector problem. And for part B, we had to show that f and s will collide, and we had to find the position vector of the point of collision. And I mentioned that there are two different methods, at least that I know of, to find the answer and to find this point of collision. And I prefer. I mentioned my method approach was just to equate the two, x sub f and x sub s, and we found that t equals 50, and we substitute that back into one of these, and we find the vector for the position vector for the point of collision. There is another method, and it is what I alluded to in the last video, where if we have, say, f and s, and this, so then therefore we have a vector fs. What you would do is essentially just subtract x sub s from x sub s, or sorry, x sub s from x sub f. Yeah, right, because it has a higher value, so that would be fine. Okay, so you would subtract the two rather than equate them, and what that would look like would be something like this. Let's just rewrite x sub f and x sub s, which are right here. We found that in the last video. So we've got 7ti plus 400 plus 7t, and actually j, I'm just going to just write them this way to avoid confusion, and we're subtracting, and so we've x sub s is 500 500 I, and I've just completely messed that up. Let me just rewrite this for 1 second here. This is 7tj. That's 70i. This is 70j. So it's j. 400j and 17j. Okay, and so we're subtracting. So it's 500i minus 3ti plus 15tj. Now, so yeah, you just subtract, and I prefer to employ algebra whenever I can. It's just my preference. But here you just subtract, right? You're just solving simultaneously in essence, really, and so you're just subtracting. But you have to be very, very careful when you subtract the two. You have to watch the sign, especially. And so let's look at this. So 7ti minus negative 3ti, well, that's just going to become positive, so we have 7 plus 3, so it's 10ti. But this 500 value, 500i, this becomes negative, so it's minus 500i. And now for the j components, 400 j minus 0, so it's just going to be 400, and then we have 7tj minus 15tj, so it's going to be minus negative 8tj, right? That's 400j. So you have to be very careful when you subtract. And now what you also have to do is you have to think of a value of what's going to set our I components and our j components to equal 0, right? For both, the same value for both, I should emphasize. Well, we've already found that in the last video using a different method. We know that t equals 50, right? So let's just go with that and continue with this logic here for the sake of this little short video. So we know t equals 50 already, but if you didn't know that, you'd have to think, okay, what do I multiply this negative 8 by to get 400? So they subtract and cancel out. Likewise for 10. So we know it's 50, so let's just plug that in. So it'd be 10 times 50 I minus 500 I plus 400 j minus 8 times 50 j. Right, and so, well, 8 times 50, that's 400, so it's minus 400, so it's 400 minus 400, and that's just, of course, that's just 0, cancels out. Likewise, 10 times 50 is 500, and so it's 500i minus 500i, and that cancels in at 0, and they cancel out, so that tells us that Just essentially following the same logic when you're equating them. It tells us that okay, that's it, this value is found in both. That means that from there, in using that value, we can then write the position vector of the point of collision, essentially. So this, I don't know, this method, it's a bit more, I would call it, it's a bit more logical. You just really, because you're just thinking, okay, we have this vector fs, and just solve it simultaneously and then we just need to think about what value, or think about what value will cancel both of these to equal 0, the same value. Whereas I don't know, if you equate them, it's really, I don't know, I suppose I just prefer it just to use a bit of algebra and find t, and then we just substitute that value of t into either x sub f in this case or x sub s, and we get our position vector, and yeah, we're done. So yeah, that's just interesting to compare, I suppose, the two methods.